All right, today in chemistry lesson 9.04, we're going to work on converting, starting with a mass and ending with a mass. So in our first conversion, we just went from mole to mole. And then in the next video, we went mole to mass or mass to mole. And in this one, we're going to go the full length of the conversion spectrum. So our sample problem says that sodium peroxide reacts vigorously with water to produce hydroxide and oxygen. The unbalanced equation is as follows. So pause the video and see if you can get this balanced. Okay, welcome back. Did you have a 2, a 2, a 4, and a 1 to balance this? So I now have 4 sodium, 4 sodium. I've got 4 hydrogen, 4 hydrogen, and I've got 4, 5, 6 oxygen, 4, 5, 6 oxygen. Kind of a tough balance problem as balance problems go. So that was our first step. Our first step is always to balance the equation. The next step that we're going to do is we're going to frame up the problem. So part A says, what mass in grams of O2 is produced when 50 grams of Na2O2 reacts? So we start off, the problem tells us we have, let me make sure I'm on screen here, 50 grams of Na2O2. I'm going to put that over 1. Let me give myself lots of space because what I'm solving for is mass in grams of O2. So I'm going to put grams of O2. The next thing we want to do is we want to label what we're starting with and what we're solving for. So here I have mass, and this is going to be compound A. It's going to be in green. And I'm going to grams or mass of O2. So I'm going to be going from here to here, and you'll notice I have my diagram written at the top. One of the things I'll do if you're struggling is I'll say, where's your diagram? That diagram is going to help you find your way through these problems. So to get from mass to mole, I use the molar mass of A. So I have to find that. To go from mole to mole, I use the mole ratio. In this case, we're going to have a 2-to-1 mole ratio. And then to go from mole to mass, I need to use the molar mass of O2. So we now want to assemble our conversion factors. And I'm going to just write those beneath here. So I have the molar mass of sodium peroxide is going to be, I'm going to have 1 mole of Na2O2. And remember, molar mass is the sum of all of the elements. So sodium is 23 and oxygen is 16. So this is going to be 23 plus 23 plus 16 plus 16, which is 78. My mole ratio is 2-to-1. So I have 2 moles of Na2O2 to 1 mole of O2. My molar mass for O2, oxygen is diatomic, so this is going to be 16 plus 16. So I have 1 mole of O2 is going to be 16 grams of O2. Just as a reminder, molar mass is always grams in 1 mole. The next thing that I want to do is I want to insert my conversion factors. So mass of A to mole of A, this is the first one that I need, and I have grams on the bottom, so this can go in exactly as written. I'm going to put 1 mole of Na2O2 over 78 grams of Na2O2. Then to get from mole to mole, I need to use the mole ratio. Whoops, oh, yep. But on this one, I have Na2O2 on the top, so I'm going to have to flip this. So I'm going to put 1 mole of O2 over 2 moles of Na2O2. For the last one, I have moles on the top, so I'm going to want moles on the bottom. So I'm going to want to flip this. I'm going to put in 16 grams of O2 over 1 mole of O2. All right, let's see if I set this up correctly. I'm going to cancel my factors now. Grams of Na2O2 cancels out. Moles of Na2O2 cancels out. Moles of O2 cancels out. So I'm going to have, when I multiply and divide, 50 times 16, and that's going to be divided by 78 times 2. And that's going to give me, oops, I have a math error. I just caught it. Let me grab my whiteout. Oxygen, there's 2 of these. This should be 32. Okay, so I've got 50 times 32 divided by 78 times 2, and that is going to give me, when I multiply and divide, 10.3 grams of oxygen. So if I start with this, I can make that. All right, part B says, what mass in grams of water is needed to react completely with the Na2O2? So this was part A. Part A. So let's do part B. And I'll switch colors here. I'm going to do purple. So we're starting with is needed to react completely with the Na2O2. So the problem implies that I have the same amount of sodium peroxide, and I'm going to put that over 1. But now I want to know the mass in grams of water. So over here, I'm going to come to grams of H2O. I'm going to label. This time I'm starting with the same thing, but I'm going to water. Mass of B. Can I do that? Can I compare 2 of the reactants together? Yeah, you can compare any 2 compounds or any 2 substances in a chemical reaction. So I'm going to have the same first conversion factor, but let's go ahead and do a conversion factor assembly. So I need the molar mass of A, which is here. And I'm going to need the mole ratio between these 2, and it's 2 to 2. So we're going to write 2 moles of Na2O2 over 2 moles of H2O. And yeah, if you simplify that, that's 1 to 1. So technically you could just write 1 to 1 if you want to. I tend to not do that just because it adds another step. If you're really good at math, I'm going to change this here too. If you're good at math, it's not a problem, but I find the fewer steps that you have to handle, usually the better off you do. I'm going to want molar mass of compound B, which is water. And I know that I have 1 mole of water. Oxygen is 16 and the hydrogen is 2, so I have 16, 17, 18. It's going to be 18 grams of H2O. Now that I have my conversion factors, I need to put them in. So I have, this is number 1, this is number 2, this is number 3. This one I'm going to put in just like this. 1 mole of Na2O2 over 78 grams Na2O2. And then I have that 2 to 2 mole ratio. Maybe you want to simplify it. 2 moles. And I can't put it in like this. I have to flip it because I need moles of Na2O2 on the bottom. You might be saying, well, why can't I just skip this? If you skip it, when you go to enter your third conversion factor, you're not going to have a reference from the factor before. So I recommend you don't skip it. So I'm going to put 2 moles of Na2O2 to 2 moles of H2O. Now when I go in to put my third one in, I know I have to flip it because I have moles of water on the top. I'm going to put 18 grams of H2O over 1 mole of H2O. Make sure I set this up correctly. Grams of Na2 is going to cancel. Moles of Na2 is going to cancel. Moles of water is going to cancel. And when I multiply, divide, I get 50 times 2 times 18 divided by 78 times 2. And again, that could be simplified. And we're going to get 11.5 grams of water. Okay, in class, if you're watching this at home in class, we're going to go ahead and do some of these practice problems that you see below, and then we'll go over those together. But in terms of doing mass to mass, that's all we have from an instructional standpoint. And we don't have anything new here. So we were going through those steps again. So our takeaways are, we're still using our conversion spectrum. We balanced our equation. We labeled where we're starting from, where we're going to, or framed up our problem, and then used this to label the equation to help us use the diagram. Then we assembled our conversion factors. We put those in, canceled our units, multiplied and divided. So same thing. All right, in the next video, we're going to get into something called limiting reactant, where we start to apply these problem-solving skills a little bit. But for now, that's all we've got, and thanks for watching.